What I'm going to start off talking about is the way that we can use cardboard. By its very manufacture, it has rises and troughs that you can measure out, and it can give you accurately sized pieces that you can use to make any kind of different structure. You would not expect to use a paper cutter to cut this kind of card. It's far too thick, but what you can do is you can use it. You can use the paper cutter to help you to size the pieces up. The easiest thing to do is with a pencil. Just move this to one side for a moment. With a pencil, you can take a pencil and run it down one of the troughs. It's not going to be 100% accurate, but it's going to be pretty close, and you can cut along that length there, and what you've got now is a pretty straight line from which to work from. And hopefully, in the way that cardboard's manufactured these days, very precisely, what you can do now is you can place that underneath and make a cut that is going to be at exactly 90 degrees to the one that you've made that's run the trough. And what you do is you run a pencil along the side, and you know now that that cut here that you made along one of the troughs is going to be as close to 90 degrees as is humanly possible. And again, you can cut along that way. So for instance, for the A5 pieces of card that we're going to use, you can use this method, and again, you could measure it along, and then you could run the pencil along. But what we actually need to do is we're going to use this piece of card for the sail at the end, so I'm just showing you. And that's 21 centimetres there. And you run that along like so. That also gives you a point where you could fold this piece of card. And this is just how you can make pieces of cardboard that will be accurately sized. And that is just under 30 centimetres. But if you've looked at the way that we made the other sail for the cardboard and the car, what I need to have is 21 centimetres. So again, not actually using the blade on the paper cutter, but you've now made 3 cuts which are hopefully at right angles to each other. You don't necessarily have to use the pencil. You can actually use the scissors. Cut along there. You've now got a pretty accurate piece of card that is 21 centimetres by 21 centimetres, and the corners will be very close to being 90 degrees. To make a working cardboard car like this one, you're going to need to have 2 pieces of A5 cardboard. 2 pieces of cardboard that are approximately 21 by 25 centimetres long. 2 pieces of card which are approximately 8 centimetres by 30 centimetres long. 4 pieces of card that you're going to use for the axles. A paper cutter. Some glue. Some scissors. A ruler. A pencil, a hole punch, 4 straws, 4 wheels, a glue gun, some jumbo paper clips, and finally a piece of card that is approximately A4 squared, that is 30 centimetres by 30 centimetres. Now we're looking at how we're going to construct the chassis of the car using cardboard. If you've used the method that I've shown you already, where you cut along one of the pits and troughs so that it makes a straight line, and you use the paper cutter to make sure that you can get an accurate or nearly accurate 90-degree angle, you can cut two pieces of card that will be exactly A5 size, which, as I've mentioned already, it takes two pieces of A5 to make a single sheet of A4 paper. Now we need to make the girders that will form the sides of the car. And here you've cut a piece of card that is 21 centimetres long, and I can't give you an accurate measurement as to how long it has to be, because what you're going to do is you're going to use the manufacture of the cardboard to our advantage, because we'll count along 1, 2, 3, 4, 5, and on the 5th trough you run the pencil down, and that will become a place for us to fold the card. 1, 2, 3, 4, and 5th one down, like so. You know that these pieces are all going to be accurately the same size. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5 are there, and the last one, 1, 2, 3, 4, 5, like so. And you cut on this last one, like so. And now you can take the very fact that the cardboard is manufactured in such a way that all of the pits and troughs will be the same distance apart. You can fold that on top of itself like so, and that as a cardboard structure is incredibly strong. You need to glue these together, and quite often with cardboard you'll find that one side might be painted, or it doesn't actually add here as easily, but it still can be glued together by using PVA glue. There is a tendency with cardboard for it to try and return to its original shape, and to make sure that this glue sets hard and in that shape, you need to hold it in place. Now you could place a heavy weight on top of it, but one of the things that I've found that is particularly useful are these things. Jumbo paper clips. Quite often we're not 100% sure what to do with half of the equipment we might find in the classroom, but with these jumbo paper clips you can open them up and push them in place, and you can leave that, kind of, I'll just show you exactly the same way as you would use it with paper, but you need to bend it slightly so that it opens out with the two rounded points together like that. You push it in place and you can leave that, and within about 2 hours, or if you have more time you can leave it overnight. That will set, and that will make a fantastically strong structure. Here is one that's been left and made, and with it being cut from cardboard and it's being 21 centimetres long, you would take these girders, and again with the cut edge placed to the inside, you would place it on there. And with this one, just have to assume that it's going to set. You place the glue on top of the side that you've just glued, run it along the length of the sides. I hope you notice that it doesn't take gallons and gallons of glue to do this. The other trick is that you place it down and you move it around. It is best if you can make sure that there is a straight line from the side of the base card. And again, put some glue on this edge here. These cardboard girders can stand to take quite a lot of weight. And again, you place that on top of there, aligning it with the side of the card. So now you have the basic structure. Two girders for the sides in line with the side of this piece of A5 card. And if you remember from when we made the paper car, we need to fit a girder inside of there. For the paper car, it actually was 8 centimetres across. But cardboard isn't like paper because it has a certain depth to it. So it's a different size, and in this case, It's now 7 centimetres across to fit into that place. It is incredibly important to use the same pieces of cardboard as you've used for the sides. Different manufacturers make different depths of cardboard. So what you could do is, in the same way as we've done it before, we have a straight edge here. This is actually 9 centimetres across. So place this in here, slightly too long. Remember, you're not cutting this with the cutter, you're just using the guide of the post and the cutting edge. Place that in line like so. And I have the ruler or the scissors along that line. Cut that out, and now you've got an accurately measured piece of card with the strength of the material running the length of the piece of card here. And what we need to do is, in exactly the same way as we did before, it will be 1, 2, 3, 4, 5, pencil along and fold, 1, 3, 4, 5, pencil along, 1, 2, 3, 4, 5, like so, 1, 2, 3, 4, 5, and like so, and just one more, 1, 2, 3, 4, 5. You cut on the last one. Again, if you fold those on top of themselves like that, that will become a girder. A girder that looks like that. So now, with our basic structure of the A5 card at the base, we can now place in there our formed girders that will hold it in place. Now the beauty of this is, if you've measured your card and that fits on top, and we would then stick this piece of card on the top, and you've made the basic and standard car. And this, when it's all glued together and hardened, is an incredibly strong structure. That has a great load bearing potential. It's very strong. It obviously makes the car, that's made out of cardboard, very strong indeed. Now that we've got all of the girders in place, all we need to do now is place the other piece of A5 card on top of this, just to complete the strength and the structure. There is something satisfying in the fact that you know that with just a little bit of effort you've cut some component parts that will all be very accurately matched. There's not the same degree of tension that you would put into this kind of car as to when you're making the paper car. Just put that in place, line it up. It is very important to make sure that these edges are as flat and as close together as possible, and you can see what you've done is you've sandwiched these things together like that, and that does become an incredibly strong structure. What we can do now is we can use the leftovers from making the smaller girders and use those to make hubs to attach the axles to the car. And again, if you just count out 1, 3, 4, 5, fall down, 1, 2, 3, 4, 5, fall down, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and down like so. And this time we'll cut each of these out. These are now 4 ridges wide, 7 centimetres long, and that is an ideal length for making the hubs that will go with this cardboard car. What we need to do now is we need to make the hubs that are going to carry the axles that are going to be on the side of the cardboard car. In exactly the same way as we did with the paper car, you've cut these 4 pieces of cardboard, and they are pretty accurate in size. It is, after all, just a cardboard car. You wouldn't be able to put 2 pieces together, but you can place the cardboard inside of the hole cutter it's in line with where it joins onto the stand, it's flush against the back of here, and it pierces a hole. Again, you put it inside, rests against the back of the stand, in line with the edge of the holder, and you've now got holes that are in exactly the same place. In total you need to make 4. And you can guarantee that doing it in this way, it starts to become very accurate. Again, pencil inside, move it around so that the axle can move freely without any kind of friction. Ideally, if you have crayons, you could use a crayon on the inside. I've mentioned before already about the amount of language that comes from this. Slippy, the fact that you're reducing friction, the fact that you can introduce momentum. And sure enough, there you have 4 pieces of card, all pretty accurately the same, with the hole in the same place. When you've left the chassis of the car to dry overnight, you can then attach the hubs that are going to carry the axles and the wheels. Just to make sure that you have the best load bearing capacity, it's always best if you place the holes, which you see aren't exactly in the middle, but they are slightly to one side. What you would do is you would make sure that those holes are more towards the front of the car itself. Again, purely and simply attach by placing glue on. If by any chance you find that the chassis isn't exactly straight, you can always chop a little bit off to make sure that you've got some kind of adhesion for the glue. When you've attached the hubs to the side of the car, it's now the time to make sure that we can place the axles. There would be no point in sticking the wheels directly on because they wouldn't revolve then. And what I've been using have been straws. Straws that, because this is made out of cardboard, it is strong, but it also has a weight. And I've found that with just attaching ordinary straws and not putting anything inside of them, that they would bend under the weight of the car. What I would do to counteract that and make sure that they didn't bend at the point where they're used for drinking is to cut some of the straw off, slit it along its length, squeeze it on top of itself, and to make sure that the kink in the straw doesn't break, you push it inside like that. If you can see now, that part, which is where it would normally bend, has a double layer of straw inside of it, and it stops it from bending. To show you that one more time, you cut some of the straw, slit along its length. You need to squeeze it rather than twist it. You take that and you push it inside of the other straw so that it goes past the flexible part of the straw. Push it in like so, and that's now strengthened that part of the straw. You can attach the wheels. You can try, this is an activity that you would be doing with much older children, so they would have the patience to attach the straw by using PVA glue, but it is much easier and quicker to use a glue gun. And you place a single drop of glue in the centre of the cardboard wheel, push the straw in, revolve it, and here we'll have the ability, with such a strong structure, to put it inside and just make sure that that wheel is as centred as it's likely to be. And again, take a wheel, place a drop of glue at its centre, It's held in place. I'm going to let it revolve. And that tends to let the wheels centre themselves. And when the glue is solidified, then you can use that to let the car run. And the glue solidified, and there you have it, a strong working mobile car. To make the sail, you take the piece that we cut earlier, which is 21 centimetres by 21 centimetres, and you can place the piece of card underneath the line of the paper cutter and run the scissors. And when you're doing the folding like this across the grain, it is very important that you make sure that you pierce each and every one of these pits and troughs that you have here to make sure that you can fold it. Okay. Again, you place it so that you're going from the other corner. It would be almost impossible to make an accurate fold if you were to try and fold this by hand. But again, you make sure that you pierce each and every one of the pits and troughs that are in the cardboard. And again, that makes an easy fold. And to make the sail, it's exactly the same way. You cut from one corner to the next, then come to the middle, and then fold it over and make it into a triangular pyramid. That, of course, will be placed on top of the car and can be used to power it by wind.